Hope you guys are doing well. So let me check if the stream is up and running. Just give me a minute. So our stream is up and running. Uh, so today we would be continuing our journey in Python. So we had already learned about functions, right? We said functions were first class citizens, right? And we also saw some so we also saw some code snippets. We'll go on from there, and then we'll try to complete little bit more about functions. Okay, so before we do that, uh, let me have my let me have this thing changed. So what I can do is, let me add a new yeah, I hope my screen is oh, this is a better alignment as compared to opacity has to go down. Okay, so we already saw something about functions, right? We said functions are yeah, let's see. Stroke width. So we said functions are first class citizens, right? And then we saw some special functions such as filter. We saw map. Now then we discussed something called as iterable. So iterable is something that can be looped, right? An iterator is basically a pattern where we have two important, because this is going to give one by one result, right? So we have two special methods here. We have next and then we have previous. So what does next is going to give the next element, and previous is going to give the previous element, right? So we saw all that. Now we are going to go a bit deeper about how Python works behind the scenes, and then we will see a little bit about uh, so we'll see Python working, and then we'll try to understand a little bit about sync and asynchronous. How does Python do a uh, what do you say, um how does Python do asynchronous features, because Python also has asynchronous capabilities, right? So we'll see that all. So first is basically, let's see how does Python code work, right? So first what we do is basically, let's write on a function, right? So suppose I have a function. So this is def, this is greet, and then this is basically, so what Python does is, first is Python internally perform in, first is lexical analysis, right? So it is going to break the code into tokens. It builds an abstract syntax tree, and that syntax tree is converted to a bytecode that is platform independent, right? Now this bytecode is stored in a .pyc file inside the underscore underscore pycache underscore underscore. So functions that start with so they have something called as magic methods, right? So if there is any function that starts with underscore underscore, these are called as magic methods, right? So you have something called as um, we have something called as magic methods, right? So what this means is, there are certain methods in Python, those have additional capabilities, right? So basically this has additional capabilities or functions. So basically first what is going to happen is, this code is going to get converted into a so first what happens is, set of tokens are generated, right? So I said set of tokens are generated. Now what does this do is, basically it is going to do lexical analysis, right? So by that, basically uh, what we mean to say is, okay, so when we think about lexical analysis, basically uh, for example, if I have a code, right? So I am saying um, so if this is def, I'm just writing a function, right? We also saw what parameters are, what arguments are, and I have to return a plus b. So now what is going to happen is, so tokens are generated. Now remember, this def is basically a keyword, right? Then this add is basically an identifier for the function. So then this is basically the return statement. Uh, this is again a keyword, right? And again I have an identifier a, and then I have an identifier b. Now this plus sign is nothing but an operator, right? But this again is indentation, right? Or delimiter in more simpler terms. Now again, this is again delimiters, right? So you have this parenthesis again. So basically what I'm going to do is, I'm just going to, the way it works is, we are just going to create a series of listings. So basically, so it will be like, um this is my, so my keyword is, say, um def, and then I have identifier, and then I have delimiter comma, then I have again an identifier a, then I have an identifier b, then Further down we have the keyword, right? So keyword is return. Then I have an operator. So basically what I have done is I have generated a tokens, right? Now once the token is generated, then I'm going to generate the abstract. So abstract tree is what we are going to generate, right? So what is abstract tree is basically a tree representation of the source code. For example, um, for example, I'm doing x equal to, so the tree. Okay, so remember, so there are two things, right? One is associativity, right? Basically in which how to read the operators. So what I'm going to do is I'm going to generate a tree. For example, this is assignment, and then I have target x, value add, and then I have left a, right, multiply. So basically this is I'm reading. So what is this is simultaneously reading the operations as well, right? Associativity is first is, so if the rule of associativity is that first a multiplication operation has to come, right? So then um, yeah, so the rule of thumb says that the first the associative, so the multiplication operation has to come. So this is the first multiplication operation that is being generated. Can I move this tab down? No. The next thing basically that I have is, so now how to read. So remember we are going to read from left to right, right? So we are going to read from left to, so then we am going to do a plus b, right? So then I have here a, and then this is my a, left a, then I have right, multiply, and then again I'm going to do two things, right? I have left b and right. This is how basically that abstract tree is getting generated, right? So simultaneously it is basically a tree like structure um, of the source code. Now it basically going to represent the hierarchical relationship, right? Now this is how the Python interpreter or compiler is going to understand the logic, right? At a low level, if you see everything, every logic will be either be an arithmetic operation, right? And then now once the ECT or the abstract tree is generated, now I'm going to parse this and going to generate now I'm going to do compilation, right? So now I'm going to perform compilation, and now is what I'm going to generate the bytecode. Now why do we need bytecode? See, for execution to give it to CPU, right? You need something that is 1 and 0s, right? However, we do not go to the CPU. What we do is we create a PVM or a virtual, and so when the OS schedules it, internally it already has a Python virtual machine that is running, right? So it's the so the OS creates a process for that, which is going to run in the CPU, but the PVM is what is going to run our bytecode. So now, as we are generating the bytecode, there is no need for one thing that this does is, firstly it makes independent of the machine code, right? So this is a very good point. Like whenever you have a bytecode generation taking place, you can run the same code in any machine irrespective of what OS you're using, right? And the only thing that you need is basically PVM. So we all might be thinking that the OS is going to it's the CPU that is going to run the code, right? So I mean, this does not happen. What happens is, so you have a okay. Let's break this down even further so that we can understand more. So basically, what happens is, so you have two core features. One, you have the PVM, and then you have something called as memory management, right? So remember, um, although the CPU can run the bytecode. So when this is scheduled by the OS, so when the OS based on certain algorithm, it can be round robin, however preemptive, non-preemptive, however is the OS made. So based on certain algorithm, this is going to get certain CPU time, right? So what does OS do is, so OS will create a process for it. Now process has different block, right? For example, one block will have um, the process ID. Why is this? Yeah, let's get rid of this. One block is going to have the process ID. Then you are going to have the stack and the memory. Yeah, let's, so this is the process ID, PID. Then you are going to have the actual memory, right? Remember, this is not what is going to happen. This is just a virtual representation of how memory works. So once and now this process is going to go to the CPU, right? Now PVM is all, so the virtual machine is already present, right? So it's, so once I go on the CPU, is the PVM that is going to execute the code, right? It's not the CPU that is working on it. So it's job of the PVM that is going to run the byte level, right? Is the PVM that is present at the logic layer. Um, yeah, and on the back, it's basically the CPU that is running, but then it's not exactly the CPU. It's PVM. It's the CPU. The CPU will be allocated for the process, right? Whenever we say process, so at that time CPU is going to get allocated, right? Yeah, so basically whenever you run a Python script, right, in the background, so you have something called as Python myscript.py. That process is generated for it. Now that has the bytecode, all the memory space, the heap memory and stack. Remember, heap memory stack is basically a virtual representation of the CPU. It is now how actually CPU is like actually CPU is not divided. We say, because whenever we say, right, we don't give the physical address because we do something called as a logical plus physical addressing, right? So the reason for us to have that logical is basically to segment or to divide the memory block into different areas, right? Like that is one core functionality that we whenever we are studying. So for example, whenever you are studying any processor, right, there is a special topic called as segmentation, right? We don't directly have the memory itself. It's basically the how do you say, behind the scenes, Like it's basically like a logic or a virtual addressing thing that happens. uh, Physically CPU is one, right? CPU is going to read from the RAM, so the RAM is one. So why do we do segmentation is because remember CPU needs a 16-bit address, right, to work. However, physical addresses are not 16 bits, right? So we don't want to waste the bits, right? So we do logical addressing plus physical, right? So remember, um, yeah, we define memory segmentation is basically to avoid bit wastage, right? Because we cannot, um, I mean, it gives us flexibility to grow, and each region has a boundary, right? So, and CPU needs a 16-bit address, right? So, for example, if you see in 80, 86 or 87, that is why we do. Remember segmentation, um, it it basically divides the memory into different areas. However, these memories are still in limited in size. So whenever you do a function call, right? So now the thing to understand with functions calls is how functions. So we say functions are first class citizens, right? So how does uh, a function call come on the stack? This is something little bit interesting to learn about. Um, so what happens is, um, now this is very cool. Like this is something complicated that we need to take care, right? Now, uh, so remember we are, so you can say PVM is like a CPU, right? But it's not exactly like a CPU. It's a virtual CPU. On in reality, it's the CPU that is doing the work, but PVM is just like a virtual machine that is going to do for you. Now, the thing is, PVM is a bit optimized as compared to directly running it on CPU, right? Now, what happens is when the PVM, so inside the, if you see in Python, you have two areas, right? One is this PVM, and this is the memory. So this is basically like the CPU RAM, right? You will be having different segments present here. So what happens is now since the PVM is going to read the bytecode, right, from the memory. Now whenever it sees a function, what it is going to do is it is going to put that function in the stack area. So it is going to place it in the stack area of the memory, right? Now for every function call, Python creates a new stack frame. Now remember, the size of the stack is limited. So if you add 10 two functions, too many calls or too many recursive calls that are not ending, then you may get a stack overflow error. So although the function is a first class citizen, um, now how does the in how it comes to know, like when should we pop this out from the frame, right? Now whenever the reference is lost, it is popped out of the stack. So this is a very crucial function, right? Whenever it feels that the function is no longer need. Now when does it feel is basically, for example, if you are having an inner function and you're trying to do closure, right? You're going to return that inner function scope, but then logically what should happen is, so you're going to call the outer one, but then you're going to return the inner, right? But because the inner is still containing the outer scope, the reference is still held. So if you have anything that is going to hold in the reference, it is still going to be present in the stack frame, right? So one important thing is PVM PVM versus CPU, right? I mean, why should we not also now remember, CPU doesn't work on bytecode, right? You need something called as binary opcodes, right? For example, move, add, jump. So how does that linking happen? Oh, so PVM, yeah, there was a wrong thing. So PVM interprets this bytecode. Now, when we say it's interpreting, is what it's going to do is it's going to generate the opcode, I guess. Yeah, okay. So the PVM job is basic. Oh, so I didn't make a mistake, right? I said that the CPU executes binary or ones and zeros, right? No, no. CPU is going to execute opcode. Now, what is opcode? Now, opcode versus bytecode. So bytecode is basically a 1 and 0 file. Opcode is basically a more uh, it's a more like a more machine level instruction. It's directly used by the CPU. For example, add, move, jump. Uh, these are a Python bytecode instruction which are basically set in the virtual machine, right? So the virtual machine is going to generate the opcode. This opcode is what is going to be run by the CPU, right? For example, move, add. These are basically opcodes. Now, okay, so PVM does this opcode to sorry the bytecode to opcode conversion. Oh, so yeah, because we are having that bytecode being readily available. Um, so Python PVM reads the bytecode and it calls precompiled C handler. Now C handlers is basically uh, so basically PVM is doing that. Oh, remember? Yeah, there is something called as CPY that is working, right? So bytecode basically triggers C functions. Now these C functions are basically going to call the already compiled CPU and the CPU runs it, right? So PVM is basically bytecode and it's going to call in some C functions. So PVM calls in, yeah, the PVM dispatch is going to call basically in C Python. It interprets the bytecode and then it's going to call the corresponding C, right? So remember we say C is very fast because it's directly can be, oh, so hence we say C language is hardware language, right? Yeah. So remember when you're doing coding, for example, you're going to um, it's the closest high level language to hardware. However, it is still human portable, right? But then, uh, yeah, you have direct access. You have more. So whenever we say, for example, we are using fork, these are all C functions, right? It's a very close representation to uh, towards hardware. So whenever you are using, for example, something called as hardware embedded system programming, right? It's mostly done in C. It's because it's more closer as compared to other language. So let's just give a brief recap, right, of what is going to. So right now we are not dealing with asynchronous nature of Python, right? We are just saying, we are still in the synchronous function. There is no asynchronous handling that we are going to do here. We are just um doing more sort of from we write a code to how does Python or the computer runs it. So we are not dealing with asynchronous nature of Python yet. Remember, Python can be used asynchronously as well, right? It's a very important feature that Python provides. So now first what is going to happen is uh, okay. So remember what is going to happen is, so there are two important components present in the PVM, in two, there are two important components that we have in Python, right? So let's say it this way. So one is the Python virtual machine, and then the other is the memory that is going to manage, right? So now this PVM is going to um okay. Oh no, this is not. Yeah, this PVM is going to be called from the memory management, right? This PVM may be this PVM is going to refer from the memory management, and what this PVM does is, now it is going to dispatch C functions, right? So C functions are going to get called, which are very closer to the hardware, and which in turn is basically uh, going to call which is basically in turn going to call our what do you say, going to the CPU, right? So first is we generate tokens, then we generate the tree is then brought to the memory, right? Basically it's a virtual representation. We then start compiling the tree, and then we check for logical errors at that stage. So so you hence there is a reason, right, why if you have a compilation error at the last stage, still um till still still the line before the compilation error, or when you have a syntactical error, that will be still executed. It's because we are going to read the AC, the abstract tree, right? We are going to traverse that tree down. So at the moment we reach to the last step, oh, we see we have a syntactical error, so that only that line will not execute, and then anything written below it will not execute, but anything written above it, till the time we don't find any errors or logical errors or any syntactical, it will still run. Now what does Jupyter do is, so Jupyter provides its own kernel as well. Now Jupyter kernel, are we no Jupyter kernel is basically is does it so Goal Collab is basically something that is a cloud based. So when you're using Jupyter kernel, right, it appears that we are using a server like thing, but then is it referring to the own there are certain IP addresses that are loopback addresses, right, that do not go to the, or do not send request to the internet. mm, is it it directly accesses the memory thing? How does it access? Yeah, whenever you open Jupyter Notebook, right? Google Colab is online. It's on cloud, right? You got that? Yeah, I guess it has already those libraries installed, maybe. Uh, okay. Let's yeah, let's get this thing down. So what I need to open is terminal. Then now I'm going to do Jupyter. Yeah, so the moon. Oh, it opened it on the wrong. Let me see. Yeah, it did open, but then it opened it on the wrong tab. Oh, what happened? What happened? Let me. Uh, yeah, so you see, it's running on this local. Now, say it directly accesses all the files, right? Um, One advantage is um it already has pre-installed libraries, right? So the moment you want to say add in a file, or you want to do something else, static, for example, you want to do numpy, matplotlib, or any other thing, right? You don't need to install it. It already comes with the package, I guess. But we say it as a kernel, right? So the thing is, yeah, it's this is in the browser, right? Remember, the browser can only understand three things. It has to be HTML, CMS, or JavaScript. This is none of them. So now what we need to do is to understand, we need to do something. Some engine or something else we need. So unlike a script where everything resets. Okay, yeah. Now this is something about specifically about Jupyter, right? So it runs in the. Oh, what happened? Let's go back. So you have different kernels. This is something that I was saying. So when I go to file, I do open. Okay, let's not do open. What you can do is you can go here. I don't want to open script. I want to go to. Let's go to the home. Let's go to files and new. Yeah, let's open a. I have a terminal open now. Let's go to file and let's view. Does it show me the kernels? No. So there is some. No, this I also if I close this. So I have this is kernel. Mm, there should be an option to say. So you go to file, view, settings, and there should be a. Mm, so okay. So basically, so this is our. So this is our Python kernel, right? Now, why does Jupyter need a kernel? Um. Okay, so basically, this is a browser, right? So remember, this kernel is going to open in the browser. Now, browser is basically having two capabilities, right? One is first is it can only understand HTML, CSS, and JavaScript, right? So Python is none of them. So you need something to understand this Python, right? So what we do is whenever you create a file, you kind of attach it to a kernel to uh, basically to run or to remember or to have a stateful feature like thing, right? It basically sends it to the kernel. The kernel interprets, compiles, and runs. So yeah, so that's why whenever so now what I do is, so if you see here new, it shows IPy kernel. This is something to take. So it when you create a new file here, this is going to open a IPy kernel. So I'm linking my file to this. So my file, so I can say so this file is getting linked to this ikernel, right? So this is this is important. This is going to run Python in browser. This is going to access the memory, do the execution. Now, why Jupyter kernel is Jupyter basically along when you install it, you also install multiple packages, right? So, for example, if I'm doing an import of a library, first I need to get that library itself. Yeah, so basically you already have the library as well uh, present, right? So the kernel is supposed to contain the PVM, I guess. Yeah, it makes sense now. Yeah, it already has kernel and the kernel already contains the PVM and the necessary things. So this is basically browser, right? I'm on this localhost. Uh, this is a website, and then it's not. So what it says is this is not a loopback address. Like this does go out of the. It makes our computer the server itself. So it's getting served from the computer itself, and mm, so browser sends. So it's going to send a request to localhost. So is this localhost being looped back? No, no, the localhost does not loop back, right? So there are certain IP addresses that are it's a local server. Yeah, so basically when I'm running it, I'm looping back. Yeah, so it's not going on the computer. Yeah, it's not leaving the computer itself. However, if you open Google Colab, Google Colab is a cloud-based architecture. I feel Google Colab. Yeah, it, it's a similar version of uh, Python. What do you say? Now, whenever I go to code, now this is on Drive or Gemini also as well. So you need to connect, and then so now you can. So now is when you can start writing your code over here. The thing is, this is cloud based, so this is not our RAM. Python 3 Google. So this is basically what do you say? So currently, this is something the free version. So free version provides how much disk and how much what do you say? Uh, the disk and RAM. So RAM is basically the CPU. Whenever whichever sorry the memory closer to the CPU is this. This is the hard drive. So wherever I'm running this, uh, it does have a GPU thing as well. I forgot now. You can do. There was a way to add in GPUs. Yeah, you see, it TensorFlow with GPUs. Yeah, this is what I was talking about. See, you see speed, and you're calling CPU GPU, right? So, Google Colab is a cloud-based thing. It's Google Cloud-based. Yeah, free access to GPUs. No installation required. Provided by Google. Comes with Google. So there will be a kernel as well somewhere which is present. That is where is the connecting to a. Oh, this has I've uploaded the data set here. So where is the kernel? Where is IPython? There should be. Yeah, so it's hosted on Google data centers. Yeah, so basically when I do this connect thing, oh, that's what is going. That is what is happening. So I can do. Is there any manage sessions, right? Yeah, I can get rid of this terminate and terminate this as well. Oh, see now, the moment I reload it, yeah. So now you don't have that. Um, or there is an API as well. Now there is something which is I was just saying. Yeah, you can go to AI Studio, create our own Google. Now you can curl it on your local machine as well. Yeah, you can use this in the background itself. So now here, if you see here, there is no. See again, it will show, right. Connect to a hosted runtime, changer runtime. So if I do a changer, oh, see now I'll say what type of thing, Python or Julia. So here, and then do I need GPU, CPU? So not all are available. I guess this is TPU is. Oh, there is certain. Oh, GPU is not available. Uh, so what type of GPUs or TPUs are? Oh, I hope I'm sharing this thing. Yeah, I'm sharing. So if you see, there is the type of GPUs and TPUs are available. Okay, so I guess we need to go and buy some subscription or something. If I'm using a, remember GPU is when you are doing image processing, right? You need hardcore things. So by default, it's CPU. You can change the runtime. You can do Python or Julia, whatever you want to do. This is basically for data science thing, right? So you can connect to a customer. You can do instance, and then so basically you can connect it your own virtual machine. You can. Oh, why did I click on connecting? Oh, I can anyways disconnect it. The moment I say connected, you see it gives this RAM and disk option, right? Mm, yeah. So manage sessions again. Clear the sessions. Yeah. So basically, I guess so. Remember that Jupyter Notebook has that IPython because of certain does that because Jupyter opens in the browser cannot understand Python. um, Kernel can understand Python, so that linking is uh, happening over there. uh, so yeah, I guess that is all for this session. I hope you guys like that. I'll see you in the next one. So in the next one we'll go a little bit ahead, and we already saw how PVM does the execution, right? um the next thing that we need to understand is a little bit about asynchronous nature, right? Because Python has that ability to do asynchronous. Now we'll see what it does, and we also saw why Google Colab Google Globe is a cloud-based version of Jupyter Notebook, right? Even in the if you see the interface, right, it looks very similar to. Uh, so yeah, you can. It looks very similar to. Oh, so now if I see this thing, this is uh, okay. It's getting managed sessions is over here, right? Where was yeah. This is cool, right? So you don't need to manually go on do and connecting. Just okay, just load the site. Okay, cancel. So right now there is a getting started page, right? So I haven't connected anything. What I can do is, so if I do a print, so what is so pay attention to your the moment I hit this thing, right, this will start to connect and you will get a memory and space, and it's identifying whether you're using R, Julia or Python. If I run see this is started to connect, right? Yeah, so it's somehow the states are linked over here. I mean it's linking this thing to see now you have a RAM, and so we did some bit of computation. So if I go to sessions, now it will, yeah, this executed in 0. This is the RAM it used. It's using this much because you are having that IPython also running. So you can change the runtime. If I say runtime is, and now if I try, so R Google, okay, did it still give me? Oh, you're not subscribed. That is something else. That is not. So if I go to upgrade, yeah, so you can do Yeah, you can have faster GPUs, more memory, and this is basically how Google earns money, right? So I guess that is all for this session. I hope you guys liked it. I'll see you guys in the next one. Till that time, take care. Bye bye.